Okay, so so let's take one of the examples you just seen as a given as a case studies is like a simple robot, right? A simple robot like have some kind of actuating mechanism. Right now we have discussed what is actuating, what is actuator, right? There is sensors signal will be converting some physical quantity into some electrical quantity, and the electrical quantity will be processed by the processing system, and the processing system will be giving its output to the actuating system, like a motor, right? So here in a robot or in a electrical vehicle, the actuating system consists of either engine or a electrical motor, right? So that is kind of actuating system. There is some kind of mechanical force triggering, etc. That is actuator. So one best example of actuator is motor, DC motor, different kinds of motor. Engine is also kind of an actuator, right? So fine. Okay, so in this example, what I'm going to tell you is some case study of a robot, simple robot. Say it has two wheels, right? Two wheels. I think I have discussed two wheels, and this, sorry, the size is different, but this is your robot actually. Two wheels. Maybe there's a front wheel also, but yeah, it's quite quite understandable. Fine. So we this robot is going to a path or road, we can say for example this is a path. Now the this is a line following robot, so I'm telling this is a line following robot, line following robot, or line follower robot. There are two things, line follower robot. So what you need to sense, you need to sense the line, right? So when you design a robot, or you have to specify what kind of line it is going to sense. It is a white road or white line, or black road or black line, whatever. It will be given by specification, right? So for example, we can assume maybe we are having a white road, right? So we should know that all other areas will be black. So this is black. Outside this lane, everything is going to be black. And here, inside the lane, everything is going to be white, right? So our robot has to know whether it is passing through the white lane, or it is passing through the white part of the board, or bright part of the board. Okay. So the only thing we have to decide, what is the decision making here? What is the decision making robot has to do? Either turn left, turn right, or go straight, right? Or adjust its position. That's the only thing. It has to keep on moving. While moving, it has to adjust its position from the center of the board. So it has to. It has only two wheels. So when both wheels will go in the same direction, for example, both wheel will go or turn in the anti-clockwise or clockwise direction, we know that the robot will be going forward, right? Forward. When both vectors from this wheel, both wheel, left and right wheel, will go forward or rotate in the same direction, the robot will either go forward or will go backward. If the both wheel are flowing in clockwise direction or rotating in clockwise direction, in the same rotation velocity or same velocity, both wheels are rotating in the same direction, the robot will be going forward or backward. Okay. Now when it has to turn, maybe it is going out of the lane, out of the road. Now there will be some sensor mechanism which tells the robot now the path is going to be dark, the white portion has been, right, has been completed. It is already now your wheel is in black portion, so you have to turn to some portion. Right now we know the robot left wheel has been outside the road, so it is having the sensor maybe sensing there's a dark road, so it has to turn right, right? So what is the mechanism, how the robot can turn right? Turning right is you have to stop the right motor or right wheel, right? So here if the right wheel is stopped, what happens? If the right wheel is stopped, the robot will be having its left wheel rotating. So what happens? It will be turning. So vector, left vector is intact, right vector has been stopped. So what happens? It will be turning to right. To turn right, we have to stop the right wheel, and similarly to turn left, we have to stop the left wheel, right? So this is one option. Another option is to improve the speed of turning or turn radius. We call the turn radius. We say if you want to turn right, you should stop the right wheel, or you need to improve the turning. We have to rotate the right wheel in opposite direction. That is also better. So for example, here left wheel goes on in clockwise direction, right wheel goes in anti-clockwise direction. So the vehicle, a robot, is going to rotate in which direction? Right direction, right? For example, you have to rotate in left direction, you have to stop the left motor, or you have to rotate the left motor in opposite direction of right wheel. So it is going to turn left. Okay, so this simple thing is a simple mechanism of a autonomous robot, or a line follower robot, whatever. It's most simple mechanism. Now there's kind of switching. Now how the transistor on getting on and off, or the wheel motor is powered, it is using a switching mechanism, right? So I think this concept is clear. The robot functionality is to detect or sense the line and follow the line. So line following, whenever it is crosses outside the line, it has to come back to the white portion of white line. That's it. So this concept, simple concept, is called line follower. Okay, I think who want to go more of circuit level or more deeper basic understanding, they can follow the lecture which I have shared with you already. So the same thing I'm discussing again. Now come back to the circuit point of view. Now we know how to turn left and right. So that is the only thing what this robot can do. Left, right, go straight, go backward. That's it, right? Now let's see what kind of circuit we need. We need to make this happen. Now I also just want to show the sensor also. The sensor will be placed somewhere like going in blue color. The sensor will be placed somewhere here, somewhere this portion sensor can be placed, right? So whenever the sensor detects a black line, now it has to tell, whenever whichever sensor detects a black line, that wheel has to continue, the opposite wheel has to stop. For example, left sensor detects, if the left sensor detects a dark path or dark road, that means it has gone outside the road. So now the left uh, now the left motor or left wheel has to go on continuously going in the same direction, but at the same time right wheel has to stop. Similarly, if the right sensor is coming in the dark portion, right now the right wheel has to go on continuously in the same direction, but the left wheel has to stop so that the robot is turning into the road again. Okay. So this is sensor. And now how the sensor works? Usually the sensor is an IR transmitter, infrared transmitter. So there will be a transmitter and receiver like this. I'm just showing the mechanism. There will be a transmitter, there will be transmitter T and a receiver R. Okay, you can wait 1 minute. Okay, so we have a transmitter. Now we need a receiver also. So the receiver is also there. The receiver is also placed here nearby the transmitter, right? Now the transmitter will be transmitting the radiation towards the road and will be received by the receiver. So when it is a white reflection surface, the receiver will be definitely receiving the transmitted IR pulses, right? When it is a dark surface, the receiver will not be receiving the transmitted pulses, right? So the same setup will be also in the right part also. There is a transmitter and there will be a receiver also, right? So that is the transmitter transmitting. With the white surface, the receiver will be receiving, right? If the dark surface, there will be no reception by the receiver. That's it. So this is the working mechanism, which I have explained in the lecture. So now let's go to circuit part. Now we have a motor. Let this be the motor. So we know motor is some converter. It kind of can say it's opposite actuator. It converts the electrical energy into mechanical energy, right? So it can either turn in the anti-clockwise or it can turn the clockwise direction. So when the current is passing from left to right, we can assume that it is rotating in the clockwise direction, right? So when the current is passing in the opposite direction, for example, it is passing in the opposite direction, you should remember that it will be turning in the anti-clockwise direction. Okay, so this effect we can use the motor to either to go forward or backward. Okay, now how to make the current go in both opposite directions? Say, for example, let us design a motor which need to rotate in the clockwise direction. So it'll be like this. So I can keep a switch here, right? Again, a switch here and power supply VCC here. So this is S1, this is S2. When I make S1 on or S2 on or both on, I know that there will be current passing from VCC to the ground and the motor will be rotating in the clockwise direction, right? And whenever we have a right, when this is S1 and S2 are off, we know there is no current in the motor. Now I'll make another setup, VCC and another switch here, another switch here. I call S3 and another switch S4, S4 here. Now when S3 and S4 is on, we know the current direction will be going from right to left. So now the motor will be rotating in the anti-clockwise direction, right? So if we give, so what will be the S3 and S1, S2 and S3, S4? There will be some switches. So we know the transistor can work as switches, right? So if I replace S1, S2, S3, S4 with switches, so I just need to control those switches, right? I just need to control like the pipe. If I make the pipe on, the water is flowing. If I make the pipe off, water is stopped. So likewise, if I use transistor for switches, I'll be making a setup called H bridge. So we can see this shape of H. You can see this is the shape of H. This is one, this is H bridge. This is called H bridge. So this is standard robot actuating system or robot direction controlling mechanism where the robot will be controlled by single motor, right? So single wheel will be connected to single motor and that wheel is controlled by the H bridge. If the current direction is forward, the motor will go in clockwise direction, and if current is in reverse direction, it will rotate in anti-clockwise direction. Likewise, if there are two wheels, I need two H bridges to control the left and right wheel through left and right motors, right? So basically, these motors will be identical motors. If both RPMs of the motors are different, you can say the robot will be always rotating either left or right. If the right motor is faster, it will going to rotate into the right direction. If the left motor is faster or have more RPM, it will be rotating to left direction. Okay, so this setup is called H bridge. Now this S1, S2, S3, S4 is replaced by transistor. It's going to be replaced by transistors. So this is going to be, we can say it can be BJT or MOSFET also. So this is a transistor. So this is transistor. So this is, can call this is T1. This is T2, right? So whenever I give a trigger signal or on signal to T1 and T2, your motor is going to rotate in clockwise direction. right? So now in the opposite direction, now we need another transistor here. This is T3 and this is T4. Now both transistor on, T3 and T4 on, the motor is going to rotate in the anti-clockwise direction, right? Because the current is going from right to left. Okay. So this, now we can say we have two controlling mechanism. Whether T1 and T2 are on, we can say 1. I'll write this is 1. If T1 equal to 1 or high and T2 equal to 1 or high, or the base signal of T1 and T2 are high, given high, the motor will be going in the forward direction, right? And if if T1 and T2 are 0 and T4 and T3 are 1, we know the robot or the motor will be going in the opposite direction, right? So we can write a truth table or input output table using this principle. So going forward. So T1 equal to 1, T2 equal to 1. Going backward or backward, reverse. So here I need T3 equal to 1, T4 equal to 1. So now at the same time forward direction, T3 should be 0, T3 should be 0, and T4 also should be 0. And the backward direction T1 equal to 0 and T2 equal to 0. So this is, we can say, the input output diagram for going backward and forward. Now what about turning? If you want to turn if you want to turn the robot to left side, so okay, so left side one motor will be turning or putting off. If what is the off condition? If we are not rotating in any direction, we can say all this transistor can be off. Okay, so that's it. So you can, if you're going thinking of digitally, you can say that we can make a truth table out of it, and we can see that always these two signals are always in opposite. T1 and T3 are always opposite. T1 and T4 are always opposite. Same time, we can see same thing is bottom. You can see an inverter. We can use inverter logic, right? So some signal is coming. I'm using inverter. Say for example T1, T3 is inverted signal of T, and the same signal is also same signal. I can use it for T2. T2 and T1 are always same signal, and the same signal in the output I can use it for T4. Okay, so this is some very simple arrangement which you used to make for design for H bridges. Okay, so the basic thing is introducing you the H bridge, which is a simple application of transistor as a switch. Okay, some other application I want to touch upon is, I think this is clear. If anyone has doubt, they can ask. H bridge concept. Okay, so what we have done, I'll just draw in fast. So we need a motor. We need to control a motor. So this is VCC. So we have four switches: S1, S2, S3, S4. These switches will be controlling the current flow through the motor. That is a simple principle. Although the terminology doesn't matter, whichever S1, S2 you can just. So this is the H bridge. Right? We need two H bridges for two wheels, or one H bridge is required to control one motor. Okay, the direction can be controlled likewise. Okay, so now another application of transistor I can say is for the lighting system. For example, we have a VDD, we have a lamp. We can use a MOSFET to control this lamp, right? So this is a lamp which I need to make it on. Now, usually I can have simple switch here, simple switch, small voltage input. This is S1. So in your home there may be some small lamp which is electronically controlled, your lighting lamp or your table lamp kind of thing. So there's a question, why I need to control the lamp like this using a MOSFET, the circuit. This is N MOSFET. I'm using N MOSFET. When the switch S1 is on, the MOSFET gate control is on and light will be on. Okay, light will be on. So when the switch is off, the MOSFET is off and the light will be shut down. Right? I think you can know that this is the application of again transistor as a switch, a simple switching mechanism. This is the simple mechanism representation of this thing. VDD. This is the light. This is the switch. S1. So this S1 is represented by the circuit here. So the question is, why I need a MOSFET here? Why can't I have a directly switch here, like in the figure given here? Is it okay, or is there what are the advantages of having a MOSFET? Can someone tell me? You can see the one advantage of this circuit is it's the MOSFET circuit helps in isolation. We know that MOSFET, the gate voltage is, there is no gate current. That is very important. Why there is no gate current? Because it is an insulation MOSFET metal oxide. This is oxide semiconductor between the gate and the transistor channel body, right? So it is, there is a insulator passing through in between. Okay, so so what happens is there is an insulation, so there is no current. So one advantage is insulation. So advantage here is insulation. I'm getting insulation. Insulation. So what is insulation? I'm getting some kind of protection from high voltage or line voltage, you can say. So this insulation here in this circuit, there are two circuits. One is low voltage circuit and the high voltage circuit. So here the low voltage circuit, this is the low voltage circuit. This part is the low voltage circuit. Low voltage circuit. Why? Because I need a very small voltage to on a MOSFET, maybe 2 volt, 3 volt, even a power MOSFET, we need a very less voltage to trigger or make it on. Right? So that is the gate part. Here is low voltage part, very low voltage, 4 volt or something like this. But in output part, our light is very high power light. It need a voltage of maybe 200 volt, right? Very high voltage. Maybe it is working in AC also, alternating current. So it can be different possibilities. It can be high power because we need a lot of light, or it can be a motor which is working on HP horsepower motor, few kilowatt, etc. So the high power circuit, and this is the high power circuit on the right. This is high voltage circuit or high voltage circuit on this part. Okay, so there is an insulation between low voltage circuit and high voltage circuit. And this MOSFET will be using the high voltage part. It may be a power MOSFET or high wattage MOSFET, etc. switches which is available. Okay, this kind of setup is used to control high power motors and lights and lamps, etc. Even vehicles also we can use for uh, electrical controlling electrical motors for electrical vehicles. Right. So this is another example. So this system is very simple. Using a low voltage device, you are controlling a high voltage equipment. The same principle is of relay. Relays are also the same principle. Here I'm using a transistor MOSFET for a relaying a high voltage circuit or lamp or motor. The principal diagram or basic principle is same is given in the right part of the simple switching mechanism, right? So one of the advantages is safety. We don't need to deal with the high voltage part. We can easily work in the low voltage switches, and the power will be triggered in the high voltage part, right? So this is another example of switching, right? Another example is you can use switching for gate, which we already designed. A lot of gate circuits can be designed using simple transistor switches. Okay, so another circuit I'll draw, which we have maybe we discussed a bit. So this is some kind of circuit. This is input voltage, this is output voltage. Now we have to give some kind of trigger mechanism. For example, we connect this to gate voltage together. Now you can tell me what is the I call VG, V gate or V control, or I can say VG. Okay, so how this works? What is the function of this thing? There is a N MOSFET and a P MOSFET. Here, this is the N MOSFET. This is the P MOSFET. Okay, so in what all conditions? In what all condition the V in reaches the V output? We know that V in should reach the V output when the VG is in which state? Yes, anyone? How can yes? Yeah, we can say the VG is high. You know, the NMOS is going to be on, and the PMOS is going to be also on. Why? Because VG is inverted before going to the PMOS. So VG is here. VG dash is going to, or VG bar is going to the P MOSFET. So for example, VG is high, the input of NMOS is high, gate of NMOS is giving high, it's on. So this is connected. So this is connected. Again, the VG bar is going to be 0. So the gate of PMOS is going to be 0 and it is also on. So the both transistors are on when VG is equal to high. Similarly, if VG is equal to 0, we know the NMOS is getting a 0, it is off. Again, the PMOS is getting 1, so it is also off. So both disconnection, V in is disconnection B out. This is called as a controlled gate, right? Right. This is called controlled gate. We can control the flow of input to the output, input signal to the output signal. So this is called a controlled transmission gate, right? Called transmission. You can write the name of this called transmission gate. Transmission gate. Transmission gate. TG. You can call TG. Transmission gate. So transmission gate is a junction where a control signal will decide whether the input should go to the output, right? So this is also a good example of transistor SSH. Okay, I think we'll stop it here. And if you have any doubt, I'll be happy. Or if you have any comments, you can just